Hi, everybody. Welcome to moles for compounds. And so we're going to be going back to this idea that we can calculate moles of, now we're going to call them particles, not atoms, but particles, specifically compounds and molecules. All right, so then you'll be very happy to see that we are still going to be able to use our triangles. So you have a foldable, you know how to do this already. The only thing different is that we're going to be doing molar masses of compounds, not molar masses of atoms. Everything else will remain the same. Our name for our particle will change from atom to molecule. Okay, so let's go ahead and get started. First, I can identify an element by reading a single name or seeing a single symbol. So silver would be one example, and Ag. You can also identify a compound by reading a two-part name like silver chloride or AgCl. And so we have now gotten to that point. Good news, you are building your scientific vocabulary. So we need to remember that 1 unit of an element is called an atom, and 1 unit of a compound is called a molecule or a particle. So that is good stuff to remember. And that also let me go back one. The number of moles is the number of a mole is the number of particles. And so we're going to be talking about that number of particles a little bit more and remembering to use Avogadro's number. I know you miss it, don't you? Okay, so just a review. When we're talking about molar mass of an atom, we literally have been looking up the molar mass of the atom on the periodic table. But the molar mass of compounds are now going to be calculated a little bit differently. So you will have now how to calculate the molar mass of a compound. And I'm going to move this down so we can see it. All right, so how to do that? You need to remember the mass of 1 mole of any element is found on the periodic table, and we have got to be able to calculate that by adding up all of the parts and remembering to multiply those atomic masses by the subscripts. So in a case like sodium hydroxide here, we would have 1 sodium, so 1 times 2.99, and 1 oxygen, so 1 times 16.00, and 1 hydrogen, so 1 times 1.01. And when you add that all up very nicely, you get 40.00. That's the part that's off the screen right there. Now, if there had been any subscripts, we would have to have figured those out through multiplication. So let's look at one in which there is some multiplication. So you can see here that we actually have a magnesium nitrate, and we are going to have to multiply our magnesium nitrate by a certain number of subscript that we have here. So we're going to need to figure out what that looks like. Okay, so when we are talking about, okay, how do we do this calculation? We're going to remember to multiply the atomic mass by the number of moles. So I know that there is an imaginary 1 right here, and I know that this 2 distributes inside the parentheses like this. So that means I have 1 mole of magnesium, but I have 2 moles of nitrogen, and I have 3 moles, sorry, not 3 times 2 moles, so I actually have a total of 6 moles of oxygen. So when I do that math, I am going to remember to multiply by my subscripts. Okay, so in multiplication, I find that I have 24.31, and I have 28.02, and I have 96.00. And so when I add all those up, I am going to make sure, and I'm making sure I do the math correctly right here so I don't have to redo it, and I get my molar mass will come out to 148.33. Okay, so it is a good idea to make sure that not only do you check your periodic table, which is where these atomic masses came from, but that you check your subscripts and make sure that you have distributed any numbers on the outside of the parentheses to the inside of the parentheses. Okay, so we are going to see if we can find the molar mass of aluminum acetate. And that means that we're going to have to do a couple things. And the first thing we're going to have to do is we're going to have to find the aluminum. And we're going to have to find the acetate. What do you mean, Mrs. Shira? Well, we have to find the acetate, and we're going to have to be able to look that up on our polyatomic list. And so I know to look it up on the polyatomic list because it has the ATE on it. And so I know that when I look up aluminum, I can see that aluminum has a +3 charge because of that 3 over the top of it. And when I go look at my polyatomic chart, I find out that acetate is C2H3O2. And I'm going to go ahead and put it inside parentheses, and it has a 1- charge. So what I'm really going to be calculating is going to be Al parentheses C2H3O2 with a 3 on the outside. So when I do this calculation, I'm going to have a subscript for everything to multiply by. So starting first for aluminum, I am going to have, for my aluminum, I'm going to have 1 times 26.98, which I look up on the periodic table. So I'm going to be adding 26.98. And then for my carbon, I am going to have 3 times 2 times 12.01. And I got the 12.01 by looking up carbon's molar mass on the periodic table. So that's going to be 6 times 12.01, and that gives me 72.06. And then I'm going to go on to my hydrogen. And my hydrogen, I'm going to have 3 times 3 times hydrogen's molar mass, which is 1.01. And I got that by looking it up on the periodic table. And remember, what I'm doing is I am distributing my 3 to the parts that are inside the parentheses. So that's what's going on there. And so I'm going to end up with, on that one, 9.09. And then I have finally my oxygen, and I have 3 times 2 times 16.00, and that's going to be a total of 96.00. Okay, so when I add that all up, I'm going to have 96 plus 9.09 plus 72.06 plus 26.98. And when I report my molar mass, I'm going to report it as 204.13, and the unit label will be grams per mole. Did you guys get it right? All right, so that is how I do my molar mass for aluminum acetate. All right, so what if we have to do the calculation now for if I have moles, how do I find grams? And if I have grams, how do I find moles? So let's remind you that we just calculated molar mass of aluminum acetate as 204.13 grams per mole. And if I am going to calculate grams, then I am going to be able to do my moles times molar mass. But if I need to calculate moles, then I am going to do grams divided by molar mass. And those are going to be my two operations. Okay, so now that we know the calculation that we need to do, let's go ahead and put that into play here. So if we want to calculate grams for the moles of ammonium, let me make sure that goes back again because that was not what I wanted to have happen. There we go. Finally, there we are. Okay, so if we want to calculate our grams from 350.8 moles of aluminum acetate, then to get our grams, we would take our moles, 350.8, and we would multiply it by that molar mass that we just calculated, which is 204.13. And so when we do that math, we get a really big number. It comes out to 71,609, and we needed to round that to 5 significant figures. Yay, 71,609. Okay, and so for the other one, we are going to calculate moles, and to calculate moles, we're going to take our grams, 875.0 grams, and we're going to divide it by our molar mass, which we got was 204.13. And so when we do that, we get 4.2865 moles. And that would be moles of the aluminum acetate. Okay, so let's continue on then and go ahead and see if we can calculate some more practice on the next slide. Okay, so for the next slide, we're going to have to use two triangles. And as you can see, I went ahead and put both triangles on here, and we're going to have to calculate our molar mass to be able to do this. So we got lots of work to get going. You're going to, as you know, you're going to need to know what the two calculations are. So if we need molecules, or sorry, we have molecules, and we need to find grams, our set of calculations is going to be molecules, which is our particles, divided by Avogadro's number, 6.02 times 10 to the 23. That's going to give us our moles. That calculation is our moles. Then that means that that is this part right here, and we need grams, so we're going to multiply it by the molar mass, in this case the molar mass of sodium hydroxide. So we're going to be doing that too. So let's go ahead and start by getting the molar mass of sodium hydroxide. So I'm going to be looking up the masses of sodium, oxygen, and hydrogen. So here we go. The sodium comes out to 22.99, and the oxygen comes out to 16.00, and the hydrogen comes out to 1.01. And notice I didn't multiply those by anything because each of these all just have a subscript of 1. So when I add that all together, I'm going to get 40.00 grams per mole as my molar mass. Okay, so now I know my molecules. And why is that written as 24? Oh, we got to change this number because that's written incorrectly. That should be written as 2.40 times 10 to the 19. Okay, so here we go. My molecules, 2.40 times 10 to the 19. We're going to divide that by Avogadro's number, 6.02 times 10 to the 23rd. And then we're going to multiply this result by 40.00 for the sodium hydroxide. So I'm going to go ahead and put that in my calculator. 2.4 times 10 to the 19 divided by 6.02 times 10 to the 23rd multiplied by 40. So my answer comes out to 0.00159, and I was rounding it to 3 sig figs because this was 3 sig figs right here. Did you get what I got? It came out to a really small number because we were actually dividing by a very, very large number here in Avogadro's number. Okay, let's try another example on the next slide. Oh, that was our last slide. Okay, at this time we're going to go ahead and quit, and your responsibility is the practice on the next linked assignment in your modules. Thanks everybody. Bye-bye.